So topic 5, 6, and 7 are going to be kind of shortcuts to find the missing sides of right triangles. So first on topic 5, we're going to talk about Pythagorean triples and scale factors. So what is a Pythagorean triple? It's the group of positive integers that satisfy the Pythagorean theorem. Basically, they're the nice problems that we have with the Pythagorean theorem where we get the nice answers that are whole numbers, okay? So if we look at the side length 3, 4, 5, we know that those three numbers will work in the Pythagorean theorem, okay? So the different Pythagorean triples are 3, 4, 5, and I'm going to circle 5, okay? The largest side, because the largest side is always going to represent the hypotenuse. So we have 3, 4, 5, 5, 12, 13, 8, 15, 17, 7, 24, 25, and 9, 40, 41. Okay? And so how can we use these to help us solve for missing sides of triangles? Well, we can use the idea of a greatest common factor, okay, and similarity that we already learned about. So remember, a greatest common factor is the largest number that goes into two or more numbers using division. So this number can divide into both numbers, and it's the biggest one. So let's say, let's look at example 1. It says solve for the missing side using a Pythagorean triple if possible. So the first step is I'm going to find the scale factor, or the GCF, between the two given sides, and we're going to divide. Okay? So looking at 20 and 15, I think that the number that goes into both of those is 5, and that is the biggest number. So I'm going to divide by each side by 5. 20 divided by 5 is 4, and 15 divided by 5 is 3. And what you want to make sure is that your two triangles have the same orientation and you've drawn them the same way so that you know where the sides are going, okay? And now, looking at this new triangle that I have here, I know 3, 4 as the legs. The triple family up here, 3, 4, 5, tells me that if the legs are 3 and 4, the hypotenuse, no matter what, has to be 5. Okay? So that's the step of determining the triple family, right? I'm looking at the triples and seeing which one works. And then the last step is to scale this triangle back up. If I divided by 5 here, I'm going to then multiply. Okay? So 5 times 5 gets me 25, and there's my missing side, and that's my answer. Okay? So notice, if we ever get to a point where this doesn't work, where we can't divide, we can't find a triple, we can always use still the Pythagorean theorem. Okay? So remember, that's always something that you guys can rely on. Let's look at examples 2, 3, and 4. Okay? You're gonna have to refer back to the triples, even though they're not on the screen anymore. Okay? So let's look at number 2, 24 and 26. What's the GCF between the two? And let's divide by the scale factor. So I think 24 and 26, 2. They're both even, right? So 2 should go into both of those. And remember, let's draw the triangle exactly how I see it. So this time this triangle is kind of like flipped upside down like that. Okay? So 24 divided by 2, that's going to be 12, and that's going to go up here. And 26 divided by 2, that's 13, that's going to go right here. And now it's very important to always identify the hypotenuse. So here the hypotenuse is 13. So looking back at our triples, is there a triple with the hypotenuse of 13 and a leg of 12? And that is right here. Here's my hypotenuse of 13 and the leg of 12. So that means the other side length had to be 5. So I know that this side length is 5. And then let's scale it back up. So I can do 5 times 2 and get 10 as my answer. Okay? All right, looking at example number 3. First, we're going to try to find the GCF. So 4 and 5. Well, 5 is, the only factors of 5 are 1 and 5, and the only factors of 4 are 1 and 4. Okay? So there's no GCF here. So my first idea, if there's no GCF, is to probably go and use c squared equals a squared plus b squared. Okay? But I think what a lot of you might be thinking right now is I'm looking at these two side lengths, 4 and 5, and I remember that there's a triple that involves those numbers. There's a triple that has the legs 3, 4, and 5. However, be very careful. Remember, the hypotenuse always has to be the biggest side. So I can only use this triple if the 5 is across from the right angle. Is the 5 across from the right angle here? No, the 5 is one of our legs. So this is not a triple. We can't use 3, 4, 5, and I have to then go and use the Pythagorean theorem. So let's show c squared equals a squared plus b squared. Well, c is unknown, so that's c squared equals a is 5 squared, b is 4 squared. Add 5 squared plus 4 squared together, and 25 plus 16, I believe that is it 41? I hope that's correct. Yep, 20, 30, 41. Take the square root of both sides, and that means that c, my missing side, is the square root of 41. And I'm going to leave that as my exact answer. Okay? Let's do one more example, number 4. Remember, I'm always checking for the GCF first, so my side lengths are 70 and 240. Whenever you guys have a 0 at the end, we should know that the factor of 10 always will go into that, okay? So I have 70 divided by 10 is 7, 240 divided by 10 is 24, and now I know I have found the greatest common factor because these two numbers, 7 and 24, don't have any factors that are common anymore, okay? The only factors of 7 are 1 and 7, and 24, 7 doesn't go into that, okay? So I know that I have found the greatest one. And now let's look at our triples. Is there a triple where the legs are 7 and 24, and we need to know the hypotenuse? So looking back, here are my legs, 7 and 24, and the hypotenuse is 25. So I know that this side length here has to be 25, and then I can take that and scale it back up. So if I divide it by 10, I'm going to now multiply by 10. 25 times 10 is 250. And there's my answer, okay? So good luck. This is always an option that you can do if it is part of it, if you find a triple. And remember, if not, you always go back to using the Pythagorean theorem, okay? So I'll see you in class.